Hi, hello viewers. Alright, we have a very simple question here. It's coming from NECO 2025 objective question number 30. And the question says, in an endothermic reaction, more products will be formed by dash A, constant temperature, B, decreasing the pressure, C, decreasing the temperature, D, increasing the pressure, and E, increasing the temperature. First of all, what is an endothermic reaction? An endothermic reaction is a reaction in which, when it occurs, it absorbs heat energy from its surrounding. So when this reaction occurs, the system or the place in which the reaction takes place is going to be cool, meaning that it has absorbed heat energy from its surrounding. But so how do we now represent an endothermic reaction using an equilibrium equation? So we have an element A plus an element B, because the equation is an equilibrium reaction. So we use the equilibrium sign, giving us C plus D. And we are told that the reaction is endothermic, meaning that endothermic reaction has positive delta H value. If it's an endothermic reaction, exothermic reaction is going to have negative delta H. So what will happen for us to get more of C and D? That is what the question is saying. What will happen for us to get more of C and D? That's the product. First of all, we have some option that talks about pressure. So, because we are not given if the volume of the reactant or the product, we are not given a specific volume. So if we are not given a specific volume and we are not told the state of the reacting species and the product, definitely we can't tell anything about pressure, because in the Leclerc's principle, it stated that one of the things we should talk about for equilibrium in pressures must be that the reactants or the product must have at least one substance that's in the gaseous form. So in the question, we are not told if the reactant or the product is in the gaseous form. So anything concerning pressure is ruled out. So option B, which says decreasing pressure, that should not be the answer. And D, increasing pressure, should not also be the answer. So we are left with option A, which is constant temperature, option C, and option E. So definitely, if the temperature remains constant, it will still give us the A and the B in an equilibrium position. So our temperature will not be constant. If the temperature is constant, it will still give us this equation in an equilibrium or in a balanced position. So when the equation talking about the heat temperature, we are told that in Leclerc's principle, if we have an endothermic reaction, if the temperature is increased, it will favor the forward reaction, that is the C and the D. But if the temperature is reduced, it will favor the backward reaction, that is the reactant A and B. In the reverse, if it was an exothermic reaction, if the temperature is increased, it will favor the backward reaction. If the temperature is reduced, it will favor the forward reaction. But in our question here, it says that our reaction is an endothermic reaction. So what will favor the production of C and D, that is a forward reaction in an endothermic reaction, when we talk about temperature, it is simply the increase of temperature. So when the temperature of this equilibrium system is increased, it favors the forward reaction, which is what? C and D. So that makes our answer to be E, increase in temperature. So in summary, when the temperature of an equilibrium system is increased, and that system is an endothermic reaction, more of the product will be formed. But if the temperature is decreased and it is an endothermic reaction, it will favor the product. More of the product will also be formed. So in summary, our answer is E, increase in temperature. Thank you and have a nice day.